So today I'm going to be demonstrating the McGraw-Hill's Virtual Manipulatives website. I really like this because it gives you the opportunity to use a lot of manipulatives that you may not have access to, and also students can use this at home, or if you're in the classroom and you have iPads or Chromebooks, whatever, maybe you're using stations, or if you use them in groups, or if each kid has one, and that way you don't always have to have the actual manipulatives there. So I'm just going to kind of show you the things that are here, and then we're going to do some algebra with the algebra tiles. So first of all, you can select a grade level from pre-K through the 8th grade, and it just limits the things that it shows you. For example, in backgrounds, you have some game boards, and some of them are more geared towards elementary age. So you can hover over these and see some of those. The majority of these are for younger kids, but you also have storyboards that you can choose from. And if you maybe were working a word problem, you would have a background that you could use to make a visual representation of whatever your problem is. And there's lots of those to choose from. You also have work mats. If I wanted to just use the first quadrant, maybe graphing some points here. And some pen. And put a few more. And up here. And then I can use my hand tool if maybe a student is graphing and realize they put this dot in the wrong place. You can actually move it around to wherever it needs to be instead of having to always erase things. And then also you have a straight line tool, so if I wanted to connect these with a straight line instead of trying to draw one, there we go. And I can also use my manipulatives if I wanted to put that on the graph. You have GeoBoard. I really like this one too, because if students are using this, they don't have the opportunity to pop each other with rubber bands or shoot them across the room, or see how far they can stretch them until they pop. So you can manipulate the rubber bands on the GeoBoard. Like that. On the bottom I have my hand tool, so I can move things around like I did on the graph earlier. A text tool, so I can click on here and I can type. It's not really good for if I wanted to type an equation because it doesn't have the proper formatting. If I'm doing simple things like 3x plus 2, but not if I wanted to use something like 3x squared. I also have a pen so I can write, and I'm using a touchscreen laptop, so I can just draw on the screen. If you have a Promethean board, it will also work with that. The straight line tool I used earlier. You have a ruler. There's also a stopwatch. Let's reset that. So let's see how long something takes. There's also a timer. So if we're playing a game and you have, let's say, 5 seconds to answer, I just drag it over and it'll count down for me. And I like that it's right there on the page. I'm not having to click between pages. And then we also have a protractor. And if I wanted to, let's say, I'll put this block on here. Starting at 60 degrees, and then I can move this around. Oops. And it will tell me down here 60 degrees. This moves around. You can stretch it way out, or if I had a small shape, and it will still tell me what I've got. And then I have 8 different colors here that I can choose from. Put that off. I have help menu, the remove background button, clear objects, so any manipulatives that I put up there, I can just clear those and keep my background. And then I can also print. So if I'm finished with something and I want to print that out, I just hit print screen and then the trash can. Go ahead and clear that out. I'm going to go to my backgrounds and I'm going to choose a work mat, and I'm going to go with the product mat. This one, there it is. Okay, so first I'm going to multiply 2 binomials, and I'm also at the same time going to show how the FOIL method can be seen through our virtual manipulatives. So on the top here, I'm going to do 2x plus 3, and then over here, x minus 2. So I'm doing 2x plus 3 times x minus 2. So first I want to model the equation. And you can click on the circle here and rotate things around the way you need them. So there's 2x plus 3. 1, 2, 3. And then over here I have x minus 2. So here's x minus 2. Okay, so now I'm filling in using the area. I have x times x. I'm going to get an x squared. Again, x times x gives me x squared. Now, this gives me the f in FOIL. So when I take my first terms here, first and first, so I'm going to use the text tool, and I'm just going to put an f right there. So now I'm going to move to the outside. I have x times 3. So I'm going to end up with x I wrote these backwards, so let's just move this around. Okay, now they're in the proper order. Here is my outside, x times 3, and that's what I have here. So I'm going to label that as O. Okay, and now here I have x times a negative 1. I have negative x, negative x, negative x, negative x, and this is I. Okay, so it's these terms. Negative 2 times 2x is negative 4x, which is what I have here. And then finally I have negative 1 times 1. And then I have 1, 2, 3, 4, 5, 6. Okay, so what is my answer? Let me put my L on here. There's my last terms. Negative 6, which is negative 2 times 3. So I'm visually showing what I'm doing with the FOIL method. So now I'm looking for my answer. I have here 2x squared. Okay. And now I have 3x here and I have a negative 4x here, so I'm going to have to remove my 0 pairs. There's 1, there's 2, and there's 3, and it leaves me with negative x. So minus x, and then I have negative 6 here, so minus 6. The final thing, clear that out, is doing a perfect square. So I'm going to first model x squared plus 4x plus 4, and then show you how we're going to see if it's a perfect square. So let's start with x squared plus 4x plus 4. Our students are going to model this. I have an x squared plus 4x. You can just throw these out here anywhere. Plus 4. And so in using it this way, we can explain to students that what we're doing is we're actually building a square. And it kind of makes a little more sense of what is a perfect square. So I have x squared plus 4x plus 4. And I have all these tiles here. How can I take these tiles and arrange them in a way that I make a square? So I'm going to start by putting this up here. And students would have the opportunity to move these around different ways and hopefully discover some patterns and see how they're moving things around, and they're not putting the x square here and then x square here. That they're trying to group them together in some certain way, and that we end up with the same pattern. Since it's a perfect square, we're going to have the same thing on the top and on the left side. Okay, there we go. And so now again we can look at the width. I have x plus 2. So x plus 2. I have the same thing over here, x plus 2. And then if we wanted to model that, so when we factor that, x squared plus 4x plus 4, we get x plus 2 times x plus 2, or x plus 2 squared. Okay, so that's my presentation of using McGraw-Hill's Virtual Manipulatives website. And I'm also using EasyVid Recorder. It's a free software that you can record your screen, and you can voice over with it. You can do some pretty neat things with it, and then you can upload it. I sometimes do some online tutoring, so sometimes it's helpful not only to have video chat, but to be able to do something like this and send it to a student. Maybe if I have study materials that I need to send them and I don't have access to an interactive whiteboard. This is just another option, and it's another great way that you can upload videos to YouTube or something like that to make a demonstration quick and easy. So I hope you enjoyed it.